Hi students, this is Srinivasa and you are watching KAB television. Welcome to E-Classes. ఇంటర్లో అత్యంత కీలకమైన ఫిజిక్స్ కు సంబంధించి లోతైన పరిజ్ఞానంతో బోధించేవారు అరుదుగా లభిస్తారు. అందుకే విద్యార్థులు ఇబ్బందులు పాలవుతుంటారు. సరిగ్గా ఇలాంటి వారి కోసమే KAB E-Classes నిర్వహిస్తోంది. ముఖ్యంగా IITకి ప్రిపేర్ అయ్యే వారి సౌలభ్యం కోసం అదే స్థాయిలో ఫిజిక్స్ క్లాస్ నిర్వహిస్తోంది KAB టెలివిజన్. IIT ఓరియంటెడ్గా సాగనున్న ఈనాటి క్లాస్ను డాక్టర్ శ్రీనివాస చారి బోధించబోతున్నారు. ఇవాల్టి క్లాస్లో జామెట్రికల్ ఆప్టిక్స్ చాప్టర్ని శ్రీనివాసాచారి వివరిస్తారు. డియర్ స్టూడెంట్స్, నిన్నటి ఎపిసోడ్లో జామెట్రికల్ ఆప్టిక్స్ చాప్టర్ నుంచి కొన్ని అంశాలను తెలుసుకున్నాం కదా. మరి ఈరోజు ఎపిసోడ్లో రిఫ్రాక్షన్ ఆఫ్ లైట్ ఆన్ ప్లేన్ బౌండరీ గురించి మరికొన్ని అంశాలను తెలుసుకుందాం.
Next concept is about the deviation produced by a prism is the maximum deviation. Under what conditions maximum deviation is possible? What we have seen is the deviation variation with angle of incidence is minimum at a particular value, but it's going to become maximum somewhere depending upon the angle of incidence. Angle of incidence becomes maximum at pi by 2. Therefore, deviation is going to become maximum at this angle of incidence. So delta minimum is here, delta maximum is when theta I is 90 degree. Therefore, delta maximum will be equal to pi by 2 plus theta E minus alpha. This is the deviation, maximum deviation. Similarly, theta I is maximum, theta E can be maximum, or delta maximum can also be equal to theta I plus pi by 2 minus alpha. Either of these two means whether incident angle or emergent angle, one of them is 90 degree. Deviation produced by a prism is maximum. Next, we consider the case of problems on prism, basic concept, application of this idea. Let us consider a prism of angle alpha, and a ray of light from air is incident normally on the prism. Incident ray is coming from air and incident at P normally. This angle is 90 degree. Then what happens to this light ray? Since it is normal instance, it goes undeviated after refraction through the prism material, comes across another boundary. Now, in case if this light ray grazing the second boundary means emergent angle now becomes 90 degree. Incident angle and emergent angle both are, incident angle is 0. Incident angle is 0. The reason is it is making 90 degree with the surface. Incident angle is 0. Emergent angle is 90 degree. Then, what is the refractive index of prism material for which it is possible, assuming alpha as 60 degree? Assuming an equilateral prism in air, having ray of light incident from air on the boundary is AB at 0 angle of incidence, that is normal instance, grazing emergence. This is called grazing emergence. And this is normal incidence. Grazing emergence and normal instance. In that case, how to calculate the refractive index of the prism material? For what refractive index of the prism material such passage of the ray is possible? Now, since it is grazing emergence, angle of refraction at this boundary is 90 degree, this angle must be critical angle. So therefore, since alpha is equal to theta r1 plus theta r2, but theta I is 0, therefore theta r1 is 0 here. Refraction angle here is 0 because it is normal instance. Since theta r1 is 0, theta r2 is equal to alpha, but theta r2 is E, theta E. This is critical angle, theta C. This is critical angle. Therefore, it is critical angle, theta r2 must be equal to theta C. From these three equations, what we conclude is alpha is equal to theta C. Means critical angle now equal to 60 degree. Apply Snell's law to this boundary, that is mu into sine critical angle. Critical angle is now equal to 60 degree. Therefore, mu sine theta C, sine 60 degree is equal to 1 into sine 90 degree, because emergent angle is 90 degree. From this, mu is equal to 1 by sine 60 degree, that is equal to 2 by root 3. So, the refractive index of medium is 2 by root 3. Ray which is incident normally on face AB emerges out grazing the face AC like this. That is possible. That's how we calculate the refractive index of the prism material. Another example we can consider. Now, a ray of light incident at an angle, angle of the prism is 60 degree, mu is 3 by 2, air, and it is grazing emergence, and we should calculate angle of incidence. For what angle of incidence? For this situation, angle of the prism is 60 degree and surrounding medium is air. Refractive index of the prism material is mu by 3 by 2. What angle of incidence is required for this to happen? So we write like this. This has to be theta C. This is theta r1, and theta r1 plus theta C is equal to 60 degree, because angle of the prism is sum of these two angles. Therefore, theta r1 is 60 degree minus theta C. Okay. 60 degree minus theta C is this. Therefore, applying Snell's law to this boundary, 1 into sine theta I is equal to 3 by 2 into sine